So I attended the two tutorials. The first one is variational inference and deep generative models. Let x and z be random variables, and where x is observed data and z is a latent variable. A generative model is any model that defines the joint probability pxz. So in these models, our goal is to estimate the posterior over latent variables p given the observed data. But this problem is often intractable. So variational inference, the goal of variational inference is that we approximate the posterior distribution with simple format QZ, giving some parameter, which is computable. So instead of maximize the local probability, variational inference try to maximize the evidence lower bound, which is to minimize the K-R divergence between the real posterior and the approximated posterior probability. So VI turns finally, by introducing this approximate posterior, VI turns inference into an optimization problem. Our goal is try to find a QX that to maximize the elbow. So the instructor later introduced variational autoencoders, variational autoencoder using. So still, in autoencoder, our goal is to construct X giving encode X the data into some latent variable and reconstruct X. But the likelihood is hard to compute given the latent variable. So in VAE, the goal becomes to maximize the evidence lower bound. So our model, the VAE model has two components: a generative network, which tries to reconstruct the observed data from the latent variable, and the inference network, which tries to encode data into latent variables. So we have two parameters, theta and lambda, and theta is for reconstruction, and lambda is for inference. So first, we want to compute the gradients for the generative network, because because theta is not the second term is constant, and we want to generate the gradient for the first term. So we can simply sample gradients from the generative network. And the inference network gradient, we want to compute the gradient in terms of lambda. And we can see the second term has analytic computation. So we want to generate the gradients for the first term. But this term requires some approximation by sampling. So and the generated the sample are dependent. The z is dependent on lambda. So we use a reparameterization trick to transform the z to epsilon that it doesn't depend on lambda. And the problem becomes to we just simply sample from a normal Gaussian distribution, and we sample gradients from the lambda. The second tutorial is deeper reinforcement learning for ARP. The instructors first introduce some reinforcement learning, and they show some fundamentals and overview of this problem. And they focus on a problem of deeper reinforcement learning for dialogue. And finally, they describe the challenges. First, why use IR in NLP? First, we can use IR to learn to search and reason, because because IR is designed for search from some space, so it's suitable for the search and reasoning problem. And sometimes we, instead of minimizing the surrogate loss, such as cross entropy, we want to directly optimize the metric. And we can use IR to select unlabeled data and back propagate reward to update model, because sometimes the model is not differentiable and we want IR to sample the gradients. So next is deep reinforcement learning for dialogue. As we know, sequence to sequence is the main framework for most of the dialogue models. But this model suffers from many problems. The instructors show two representative problems. The first one is repetitive response. For example, the message is shut up, and the response could be you shut up, and the response could be you shut up again and again. And so and the problem two is that the agents, the chat agents, could be short-sighted. So they don't make decisions in the long term, and they just focus on the current state. For example, how old are you? And I'm 16. 16? I don't know what you are talking about. And the response could be you don't know what you are saying, and I don't know what you are talking. So the chat could be stuck here. So in the speaker talked about their research on reinforcement learning-based dialogue model. In their model, they define state as the message encoding, and action is just the response decoding. And they define 3 rewards for reducing these 2 problems. They define ease of answering as the local probability of DAO utterance giving the response, and they define information flow to avoid this repeatedness. They define the reward of information flow as the neck log of the cosine similarity between 2 utterances. And they also define meaningfulness as the conditional log probability giving message and response. And finally, they show some challenges of IR for NLP. So the main challenge is that the natural language, the action space defined by natural language is unbounded. And IR should deal with combinational actions and external knowledge. And sometimes the reward function is hard to define, and the agent should learn reward functions. And there they point some IR problems that are particularly relevant to NLP, such as sample complexity, model-based and model-free IR, acquiring rewards. Okay. That's all my